Hi, this is Jolting Jonathan of Mad Science of Southern Massachusetts and Rhode Island. Today, I want to do a pair of experiments. I want to do some experiments involving, starting off, baking soda and vinegar, acetic acid and sodium bicarbonate. What I have right here is I have some baking soda and vinegar. And what happens when you mix baking soda and vinegar, and many of you have done this experiment where you make a volcano. It's a very common experiment in schools. And what happens is you're actually mixing a base with an acid. Sodium bicarbonate is a base and vinegar is an acid. And when you mix that, one of the things that happens is you get carbon dioxide as a byproduct. Those bubbles that you see when you make this experiment are actually carbon dioxide bubbles, and that's what makes it bubble. I want to do something a little bit different. I actually have a cap. And what I'm going to do is I've got my sodium bicarbonate inside this little soda bottle top right here, and I'm going to drop it inside this vinegar right here, and then I'm going to jam a cap inside it because I want to see if we get enough carbon dioxide that it blows the top off of this experiment. Because at Mad Science, we like to go a little bit bigger, so I want to just see how much carbon dioxide we get. I want to blow the top off this experiment. Do you think it's going to blow the top off? I don't know. So we're going to throw some goggles on just to be on the safe side. So, are we ready? Let's drop that in there. Now I've got it packed in there, so hopefully it won't spill out. And then we're going to drop it in there. We're going to drop it, put the top in there good and tight. Then we're going to give it a little shaky shake. Give it a little shaky shake. And we blew the top right out of there. And it's bubbling up. That's because when you mix an acid and a base, you get carbon dioxide as a byproduct. Now, I actually showed you that experiment because I want to show you this one. I love that experiment, but you don't always get carbon dioxide as a byproduct. Sometimes when you mix chemicals, something different happens. And I want to show you that experiment right now. This is actually a very famous experiment. This is an experiment called elephant toothpaste, even though this experiment will never be used on an elephant. To start off with, the first thing I'm going to do is I'm going to take just a little bit of regular dish detergent, and I'm just going to pour about that much dish detergent into the bottom of this container right there. And I'm going to swirl it around. And then we're going to take a chemical that can be a little bit dangerous. This is a chemical called hydrogen peroxide. And I'm going to pour the hydrogen peroxide, and I need to be careful. This is not the regular hydrogen peroxide that you use at home, okay? This is not the same stuff. This hydrogen peroxide is much stronger. The hydrogen peroxide you use at home is 3% hydrogen peroxide. This is 40% hydrogen peroxide. This is much stronger. This actually can burn you if it touches your skin. It's very, very strong. Hydrogen peroxide is actually water with an extra oxygen molecule. It's H2O2. Now, the next chemical I'm going to add is a chemical called potassium iodide. What's going to happen is this is going to take that extra oxygen molecule out. It's going to rip it out of there. And when that happens, it's an exothermic reaction. It's going to generate heat. It's going to generate a lot of heat when it rips that oxygen molecule out. But that soap that we've added in there is hopefully going to trap that oxygen molecule. Are you guys ready? Let's see what happens. And as you can see from the steam coming up, we've got a lot of heat coming out of there. There's a lot of heat coming out of there. It's warm, it's warm, it's warm, it's warm. Now I've got my stirring stick right there. Let's see what happens with my stirring stick. As you can see, that foam grabs that stirring stick. That elephant toothpaste keeps coming. It keeps coming, it keeps coming. It's roasty, toasty, roasty, roasty, toasty. It is very, very warm. All because of that amazing exothermic reaction. Look at that. It just keeps coming. It keeps coming. It keeps coming. All over the place. Look at that. Oh my gosh, this is so exciting. I am so excited right now. Oh my gosh, this is so cool. Actually, it's really, really warm. Really, 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 really warm. And I don't know if you can see it. I don't know if we can get it with this camera right here. It's still coming in. It's still coming. It's still coming. It's still coming. It is an amazing experiment. Can we actually get this side camera to come up? As you can see, we're still getting coming out right here on the side. Look at that. Oh my gosh, this is so cool. All because of that exothermic reaction. And it's finally starting to slow down, but we've still got that steam coming out, all because of that amazing experiment. Ladies and gentlemen, thank you very much for watching. If there's anything else you want to learn about, please send us an email, write to us on Facebook. Once again, I'm Jolting Jonathan with Mad Science of Southern Massachusetts and Rhode Island. Thank you very much to Bristol Community College and the Fall River Media Center. We'll see you guys soon. Thank you very much. You want to know something? Send us an email on Facebook. Send us an email to our website.